What's going on, guys? Mr. Jones coming at you once again. Today we're going to continue with Carlos and Clarita and do task 5.4. So what we're going to do in this task is I'm going to kind of go over what we've done so far, remind you of the work you've done, do a little bit of stuff from time and space. That's what we've been talking about so far. And then I'll let you guys work on these problems, but I don't want to give away all the fun. By now, you guys should be able to write these equations on your own if I just remind you of what you can already do. So we'll get there in 1 second. So Carlos and Clarita have been worried about space and startup costs for their pet sitters business, but they realize they also have a limit of the amount of time they have for taking care of the animals that they board. So to keep things fair, they have agreed on the following time constraints. So I'm going to read this first one, and then I'm going to start crossing stuff off for you guys. So here we go. First one is feeding time. They have to feed the animals, obviously. So Carlos and Clarita estimate that the cats will require 6 minutes twice a day, morning and evening, to feed and clean their litter boxes for a total of 12 minutes per day for each cat. Dogs will require 10 minutes twice a day to feed and walk for a total of 20 minutes per day for each dog. Carlos can spend up to 8 hours each day for the morning and evening feedings, but needs the middle of the day off for baseball practice and games. All right, let's do what Mr. Norman would do and cross off all the things that we don't care about. All right, so Carlos and Clarita estimate that the cats will require 6 minutes twice a day, morning and evening. I would argue that none of that matters. Who cares how much it is twice a day? Okay, we just want to know how much it is going to take every day. Okay, so all this can cross off. We don't care what time of the day it is. Okay? And we don't care what they're doing. We don't care that they're cleaning their litter boxes. All we care about is that it's 12 minutes per day for each cat. I should have underlined that in green or something. 12 minutes each day for each cat. Everything else before that doesn't matter. Okay, so don't freak yourself out with all the words. In fact, cats, we know is X. Cats, remember X is cats? This is 12 minutes per day. That's all that matters. Okay, dogs will require 10 minutes twice a day to feed and walk for a total of 20 minutes per day for each dog. So yada, 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 yada. 20 minutes per day. Dogs, 20 minutes per day. Okay, so we're going to put down here Y. Y is dogs. Y is 20 minutes per day. Okay. Carlos can spend up to 8 hours each day for the morning and evening feedings, but needs the middle of the day off, yada, yada, yada. No one cares about any of that, right? All we need to know is that Carlos can spend 8 hours each day total, right? Why did I put that in red? The world may never know. There we go. 8 hours each day total is what he has available. All the other nonsense can cross off. Cross this off, cross this off. We don't even care that it's Carlos. All we care about is that that's the total amount of time. Total time available, 8 hours per day, right? So everything is per day, per day, per day. Good. So that's all the information we need for that problem right there. Okay, I'll let you guys do this same process for the pampering time. So if you want to pause and try it, go ahead. All right, so whether you paused or not, let's go back to what we remember from before, right? Space and time. In fact, here's an example from the previous problem. So it said cats require, remember X is cats, require 6 feet of space. And dogs require 24 square feet of space, right? And the total we have is 360 available, right? So we literally have what dogs require, what cats require, what dogs require, and the total that we need in this problem. That's very similar to what we just did in red up there. What cats need, what dogs need, and the total. So let's remember the equation before, right? We said, okay, we want to maximize our space. So we said 6 feet per cat plus 24 feet per dog equals 360 feet. That was the ultimate goal. But it didn't have to equal 360 feet. It just couldn't be more, right? It just couldn't be more. So instead of putting equals 360 feet, let's say that as long as whatever this equals, the number of cats and dogs, whatever that equals, has to be less than or equal to 360, right? I had a student who I asked yesterday in tutorials to read this out loud, and he was reading the inequality backwards. You always read every equation left to right, okay? And whatever part of the symbol you come to first is what you say. Hopefully, if you look at this symbol, you know this side is less, right? And you know this side that the alligator's mouth is on is greater, right? So if you read this equation left to right, 6x plus 24y is less than, because the less than symbol is closest to the left, is less than or equal to 360, okay? So remember, that's how we got the equation before. And then we also took the equation and we were able to convert it to slope-intercept form, right? Slope-intercept form. Let's recall this previous work so you can do this other work by yourself, this practice task by yourself. Okay, how did we convert this? Well, we want it to look like this, right? Y equals mx plus b. So y by itself. So that means get rid of everything else that isn't a y on the left-hand side, okay? And you can do whatever you want as long as you do it to both sides. 6x minus 6x, no x's. 24y is what's left. We didn't multiply or divide by a negative, so our sign stays the same. And negative 6x plus 360, because you can write it in whatever order you want, and you definitely can't combine those. And now it looks like mx plus b already. Last step of getting y by itself, divide everything by 24. We didn't divide by a negative, so make sure your sign stays the same. And now you actually reduce this fraction. Okay, so 6 times 4 is 24. Okay, 6 times 4 is 24, so we know that this reduces down to negative 1/4 x, right? If we just divide, you can always reduce this fraction. Negative 1/4 x plus, and then you just go to your calculator if you don't know what this is, and you'd say, what is 360 divided by 24? And the answer is 15, okay? And this should have been a plus sign right here. But that is the equation, right? So we started off with standard form up there, which we got from cats and dogs, adding them together, having to be less than or equal to 360 square feet. And then we used our skills to convert to slope-intercept form, right? Slope-intercept form. Now, whenever you go to this task, it's going to tell you write inequalities like we just did for each of the additional time constraints. Shade the solution set for each constraint on separate coordinate grids. So now it's also going to want you to create not only equations, guys, but graphs. So let's talk about how you would create a graph for negative 1/4 x plus 15. All right, so I drew my best graph possible. I don't want to put it on Desmos because I want you guys to know that you can graph it on your own as well. Just remember y equals mx plus b, that this is my y-intercept. So we get that for free, and that's always where you want to begin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ooh, the 15. That's my first dot, my y-intercept. And now I just got to use my slope of negative 1/4 to make one more dot. Okay, one more dot. If you don't know if a line is positive or negative, remember my positive line goes this way because I have my friend Tom. He only could walk to the right. If he's going uphill, it's positive. Okay, if I draw another graph over here and it looks like this, Tom can only walk to the right. So if he's walking downhill, it's a negative slope, right? So you should have a line that looks like this line, right? Because that graph has a negative slope, so keep that in mind. All right, a slope of negative 1/4. Remember, this is your rise, this is your run, okay? So this is your up or down, and this is your left or right. Okay, so if I have a negative 1 as my rise, that typically means that I go up or down, but it's going to be down because it's negative 1, right? So negative 1 means down 1, okay, typically. 4 means right 4, because right is in the positive direction. Now, you could make both opposite movements. I don't want to confuse you now, but if the same thing as down 1, right 4, you could also do this and go up 1, left 4, and it's going to be the exact same thing. This and this is the exact same thing. But either way, I don't want to bore you to death here with slope, but let's go ahead and just do down 1, right 4. So starting at your original point, down 1, and then right 4, which is going to be about right here. Okay, so 1, 2, 3, 4 over. That's pretty good. All you need is two dots, and then you can connect the line, and we'll see how beautiful I can make it. It's supposed to go through both dots, but you get the picture. And now, let's recall what our original equation is with all this mess. It was supposed to be, let's back up a hair. What was it? Oh, y is less than or equal to. So let's go here. Y is less than or equal to negative 1/4 x plus 15. I told you in a previous video that you know which way to shade because of what you say. So as you read from left to right, if you say the word less than, you shade below. If you say the word greater than, you shade above. Y is less than. And so Mr. Norman just teaches the shade with arrows. So you're going to shade everything below the line in this direction is what you're shading. Also, the only other thing to worry about is there's an equal sign there. If there is an equal sign, your line is going to be solid. And if there isn't an equal sign, it's dotted. But I think in this problem, it's always an equal sign. So this was an example of the previous problem. Don't forget, to help you with 5.3, for those of you guys who attempted 5.3, this is actually me solving 5.3 to some degree and showing you how to graph it, shade it, and get it in standard form and slope-intercept form. So your job now, I helped you set up in red here, if you guys remember in the very beginning of the video, I help you set this up. This is feeding time, the first part. I think you guys now can come up with an equation for that, and then I think you guys can do what I did with the paragraph there, cross a bunch of stuff out for pampering time. So I'm looking for 2 standard form equations, 2 slope-intercept form equations, all with inequalities, and 2 graphs shaded. Okay, so there's really only 6 things to do for this entire task. So that's all I got. I hope you guys have a glorious day. Please, please, please hit us up if you guys have questions about this. It's usually something very small. We would love to help you. All right, guys. Adios.